Assalamu alaikum students. Today we start exercise 1.2. Composition of function and inverse of a function. Let f be a function from set x to set y and g be a function from set y to set z. One function from x to y and the other function from y to z. Composition of f and g is a function denoted by g of f from x to z. We skip the middle value like y and directly from x to z, because first function is from x to y, second is from y to z, and we skip here y and directly from x to z. And it is also written as g of f of x, g of f of x, and g. All are true values for all x belongs to x. Composition of function. We have two function, f of x 2x plus 3 and g of x x square. Now how we find g of f of x? We first put the middle function, inner function 2x plus 3, because here the second function is f of x. We put its value 2x plus 3, then we put this value in the outer function, and this is g. When we put this value in g, because g is x square, now it becomes 2x plus 3 square. We put this value in the function g, because there is square, the whole value become in square. The arrow diagram of two consecutive mapping f by g is shown in the figure. Here we have x to y and then y to z. X to y is 2x plus 3, then it moves to the second function, so it becomes 2x plus 3 whole square. Thus a single composition function is equivalent to two successive function f followed by g. Now here we have example f of x 2x plus 3 plus 1 and g of x x square minus 1, and we find here f of g of x, g of f of x. F of x is also written as f square x, and g of x g square x. We first find f of g of x. Now second function is g of x, and value of g of x is x square minus 1. We put this value in f, where we put in place of x 2x plus 1. At x we put value x square minus 1, then simplify it. Second part, g of f of x. Second function is f 2x plus 1. We put this value in g, 2x plus 1 ka square minus 1, then square and simplify. In f square we also write as f of x. Second function is also f and first is also f. We put value of f into the f, 2x plus 1. We put this value again in place of x, it becomes 2 bracket. In place of x we put 2x plus 1, and then simplify this value. And again in case g of x, g of x square minus 1, because value of g is x square minus 1. Put this value again in this equation. Now it becomes x square minus 1 whole square minus 1. Then simplify. Here we expand square, a square plus b square minus 2ab, and then simplify. Here we observe that f of g and g of f are not equal. And same note is there, f of g and g of f are not equal because g of fx means f is applied first then followed by g, whereas fg means g is applied first followed by f. We usually write f as f square and f of f as f cube, and so on. And next topic for this exercise is inverse of function. Let f be a 1 function from x on to y. 1 function means if no value of range is repeat. The inverse function f denoted by f inverse. A function from y on to x is defined by f x is equal to f inverse y, which we write f of x is equal to y. Now inverse is x is equal to f inverse y. For all y belongs to y, if and only if y is equal to f of x. Now my arrow diagram, we have x and its image is there, y is equal to f of x. Domain of f is called range of f inverse, and range of f is called domain of f inverse. Now we can find the composition of the function f into f inverse. First we find f inverse, then we find composition of the original function and its inverse, and this is always equal to the x. Our identity mapping on the domain range of f and f inverse. Now here we have example. Now algebraic method to find the inverse. We have function f of x 2x plus 1 and f inverse x. The change of name of variable in the definition of function does not change that function where the domain and range coincide. We find the inverse of f as follows. The original way how to find the inverse. We place f of x is equal to y, then we find the value of x. Here we have y is equal to 2x plus 1. We move plus 1 to the left hand side is equal to minus 1 and then divide by 2. Now we get the value of x, and this value is named as f inverse y. Then we change the variable. In place of y we write x. F inverse x is equal to 1 over 2x minus 1, and this is the inverse. Now verification, we verify it by the original function and the inverse by its composition. In first composition we f of f inverse x. Second function, if f inverse, its value is 1 over 2x minus 1, we put this value in f. 2x plus 1. In place of x we put 1 over 2x minus 1 and then simplify, and we get answer equal to x. And in second form f inverse f of x. We have second function f of x 2x plus 1. We put this value in f inverse 1 over 2 x minus 1, and in place of x we put the value of 2x plus 1 and simplify. Then again we get is equal to x. Therefore you verify the given condition. Now to find the domain and range of a function without finding f inverse, we see that it is not defined when x is less than 1. When we put any value less than 1 in square root, it gives negative answer and move toward complex number, so we avoid these values less than 1. Therefore the domain of f is greater than 1. It means its domain is 1 to plus infinity. So its range is from 0 to infinity, but addition of 2, therefore its range becomes 2 plus infinity. The range of the only radical sign x minus 1 is from 0 to infinity, because it contains plus 2. Therefore the minimum value becomes 2 and maximum is infinity. But to find the domain and range of f inverse, we change these values. Range become the domain of f inverse and domain become the range of f inverse. Okay students, try to solve these examples, and if possible do any question of exercise. Thank you and Jazakallah. Allah Hafiz.